Hey everyone, and welcome back. Today, we're going to be diving into, well, you know how you've got those large language models everyone's talking about?
Mm-hmm.
Well, we're looking at what happens when you try to put them on a data diet.
Oh, interesting.
Yeah, like say you want to run one of those super smart AI systems, but like on your phone.
Right.
Our source material for today is this research paper, and get this, it's called Can LLMs Maintain Fundamental Abilities Under KV Cache Compression?
Okay.
Yeah, catchy title, huh? But really, it's the findings that are interesting.
Yeah, it really is fascinating stuff. These LLMs, they're powerful, but they need so much memory,
Right.
like tons of it, especially when you start giving them, big chunks of text to work with.
Oh yeah, I've definitely noticed my phone like slows down when the memory gets full.
Uh-huh.
So I can only imagine what that's like on a much bigger scale.
Absolutely.
And that's what the researchers are trying to, well, to tackle here.
That's right. Every single word, every sentence, every relationship, like all the stuff the LLM has to think about, all has to be represented somewhere.
Okay.
And that somewhere it's called the KV cache.
KV caches.
It's basically like the LLM term memory. Think of it like when you're trying to solve a problem
Okay.
and you're like jotting down notes or making quick calculations in your head.
Gotcha.
That's the KV cache. It's holding all that info while the LLM is working.
So that makes sense. But as these LLMs, I mean, they keep getting more and more powerful, right? They
Right.
can work with longer and longer pieces of text.
Longer and longer contexts. Yeah.
So I bet that KV cache starts to become a problem.
It does. It can totally grow out of control. Like if you tried to, I don't know, cram a whole library into a backpack.
Yeah, good luck with that.
Yeah, exactly.
So, okay, I'm starting to see the problem here.
Yeah.
But I'm hoping researchers are, coming up with some clever ways to compress all this information.
Oh, they are, definitely. There's a whole bunch of different compression techniques out there.
Mm.
Each one's got a slightly different approach. So some of them, like streaming LLM, try to process the information in a more streamlined way.
Okay, so instead of reading the whole book at once,
Yeah, like reading it one page at a time.
that makes sense.
Yeah. Others, like SnapKV, they aim to capture the most important snapshots of the information.
Ooh, snapshots.
So kind of like if you were highlighting the key points in a textbook.
Okay, I like that analogy.
Yeah.
But let's get down to, some of the key findings here. Can you actually compress these LLMs without, like, messing up their ability to think?
Ah, well, see, that's where it gets really interesting.
Okay.
The effects of compression really depend on what you're asking the LLM to do.
So different tasks, you're saying they have different memory needs.
Exactly.
That makes sense.
Some abilities are way more sensitive to compression than others.
Okay.
Take, for example, arithmetic reasoning. If you compress the memory too much, the LLM can really struggle with, math problems.
Really?
Yeah, the researchers saw accuracy drop by like a crazy amount.
Oh, wow.
Yeah, something like 43.3%.
43%.
When they were using this benchmark called GSM-8K,
Okay.
which is basically like a set of word problems for the LLM to solve.
Oh, that's wild.
Yeah, it is.
So, like, if I was trying to do my taxes on my phone,
Right.
I might not want to compress the memory too much.
It's a good point. And it's not just math that gets affected.
Oh, okay.
Generating long, coherent responses, things like writing a story or a report that takes a hit when memory is limited.
Makes sense.
They tested this using LongGenBench GSM-8K,
Mm-hmm.
which basically has these longer responses to those GSM-8K problems.
Right. Okay. So math and longer responses, those are more memory intensive.
Yeah.
What about other stuff that LLMs are good at,
Mm-hmm.
like general knowledge or coding?
That's interesting. Those abilities seem to be more resilient.
Hmm.
They don't seem to need as much, readily accessible information.
Okay.
It's like the LLM can still kind of piece things together even with a smaller memory footprint.
Well, that's good. So it's
Yeah.
not all doom and gloom,
Right.
but I have a feeling it's not that simple, is it?
You're right. It's not quite that simple.
Okay.
There are a few other things to consider. For one, not all LLMs are created equal
Oh, okay.
when it comes to, handling compression.
So some are better than others.
Exactly. The researchers found that LLMs that are trained for what's called multi-step reasoning, meaning they can solve problems that require multiple steps.
Gotcha.
Yeah, those are surprisingly tough.
Really?
Yeah, they used a model called DeepSeek R1,
Okay.
and it held up much better than others when memory was compressed.
So they're like the marathon runners
Yes.
of the LLM world.
Exactly. They can just keep going and going.
I like that.
Yeah.
What else did they find out?
Well, the length of the prompt also matters.
The prompt.
Yeah, like the initial instructions you give to the LLM.
Right.
Shorter prompts, they're actually more vulnerable to compression.
Oh, interesting.
Yeah, because there's less context for the LLM to work with.
So it's like trying to write a novel, but you only have a sticky note. You
Exactly.
just don't have enough space.
You need more space to really develop the ideas. And this was something they observed when they tested different prompt lengths using GSM-8K.
Okay.
The fewer examples they included, the shorter the prompt became, and the LLM's performance, it really suffered when the memory was compressed.
So a longer prompt can actually help.
It seems that way, yeah. More examples can actually help to mitigate the negative effects of compression.
Interesting. Okay, so let's dig into the compression approaches themselves. The research talked about how chunk-level compression was the most effective for certain types of tasks.
Yes, for those complex reasoning tasks, especially with lots of context, that's where chunk-level compression really shines.
Chunk-level compression, can you explain that a little bit more?
Yeah, imagine you're reading like a mystery novel,
Okay, I love a good mystery.
but someone keeps ripping out random pages.
Oh, no.
Could you follow the plot?
Oh, that would be impossible.
Right.
Too many missing clues.
Too many missing clues, exactly. And that's kind of what happens with some compression methods.
Hmm.
They discard like crucial pieces of information that
Mhm.
the LLM needs to, understand what's going on. Chunk level compression, on the other hand, it tries to keep related pieces of information together.
Okay.
So think of it like instead of ripping out pages, you're ripping out entire chapters.
Oh, okay.
So you might lose some detail, but you can still kind of follow the overall narrative.
So it's all about preserving the connections
Exactly.
and a context.
Precisely. And this is where a method called ShotKV, this is where it really excels. They tested it in a scenario using GSM-8K,
Hmm.
but with a really long prompt, and it was by far the most effective way to compress the information while still allowing the LLM to perform well.
So ShotKV is the champion of complex problems.
It is.
We also talked about another method called ShotKV.
Right.
What's so special about that one?
So ShotKV takes a very clever approach.
Okay.
By treating the initial prompt, so those instructions we talked about, differently from the text that the LLM generates,
Gotcha.
it compresses them separately.
Oh, interesting.
Yeah,
So it's like two different compression strategies.
it is.
One for the input and one for the output.
Exactly.
Tell me more. So it's like it's recognizing that the prompt is like the most important part.
Uh-huh.
Like you're planting a seed.
Yeah.
You need that core information to be solid,
Right.
even if you get creative with what grows from it.
That's a great analogy. And the results are really impressive.
Okay.
Remember how we talked about those benchmarks, the ones where LLMs had to like produce longer, more detailed responses?
Yeah, those were really tough for the other methods.
They were, especially Longgen Bench GSM-8K and Many-Shot GSM-8K.
Right, those are the ones.
ShotKV, it handles those really well.
Oh, wow.
Yeah, manages to save memory, but it doesn't mess up the LLM's ability to, reason and generate those complex outputs.
It's like you have a small backpack, but you can fit everything you need for like a whole week-long hike.
Exactly. It's pretty remarkable.
It is. It seems like ShotKV, it kind of understands where to focus.
It does.
It knows where to compress so it doesn't mess up the output too much.
Exactly. It's a really promising approach, especially you need to, save memory without sacrificing performance on those tougher tasks.
Yeah, makes sense.
What's really interesting about all this research, though, is that it really shows how compressing these LLMs, it's not just a one-size-fits-all thing.
Right.
The best method really depends on what are you actually trying to do with the LLM.
So it's all about picking the right tool for the job.
Exactly.
If I'm using an LLM, should I even be thinking about compression?
It's definitely worth considering, especially if you're working on a device with limited memory, like a phone or maybe a smaller server.
Okay.
Compression can help unlock those powerful AI abilities without running into those memory problems.
So you're saying it makes these tools more accessible to everyone?
Absolutely, but like we've been talking about, it's not as simple as just squeezing the memory as much as possible.
Right.
You have to, really think about what you're asking the LLM to do.
Okay.
Choose the right compression method.
And if you don't?
You could end up with an LLM that, well, can't think straight.
Right, like that example with the taxes.
Exactly.
You don't want an LLM that can't do math when you're trying to, like, balance your checkbook.
Exactly. The takeaway is, know the task, choose the right compression, and you'll be able to use these powerful tools effectively.
No matter what device you're using.
Exactly.
Okay. This whole discussion about choosing the right types of compression, it makes me wonder, like, what if we could design completely new techniques? Ones that are specifically made for different LLM abilities.
That's a really interesting thought.
Right, so different tasks have different memory needs.
Right.
What if we had these super efficient algorithms that only keep the essential information for a particular task?
Like a custom-fit compression suit.
Exactly. Imagine running these complex AI models on even the tiny devices,
Yeah.
all thanks to these specialized compression methods.
That's a fascinating idea. It could be the next, like, big step in LLM development.
Wow.
But even with what we have now, there are still things to consider.
What do you mean?
Well, you know how when you compress a file on your computer, like you compress it too much and then the image quality gets bad
Yeah,
or the audio sounds weird?
right.
It's about finding that balance.
So with LLMs compressing too much, it could actually hurt its performance.
Exactly, even if you're saving memory. And that's why this research is so important.
Okay.
It shows that we need to understand those trade-offs and choose the right compression method for our goals.
So some methods might be great for, like, general knowledge,
Right.
but not so good for those complex reasoning tasks.
Exactly. Some might be good for like simple question answering,
Right.
but then fall short when you need a more nuanced response.
Like those multi-step reasoning models.
Exactly.
They can handle those tougher tasks.
Even with limited resources.
That's incredible. It makes me wonder, can we build LLMs that are just, like, naturally better at being compressed?
Oh, that would be amazing.
Right. Powerful and memory efficient from the start. I think this conversation, I mean, we've covered so much.
We have.
And I think our listeners have a lot to think about.
They do.
Should we wrap things up?
I think that's a great idea.
It really makes you think about where LLMs are going
It does.
and how we can make them, well, more efficient.
Yeah.
It's not just about making them smarter.
Right.
It's also got to be about making them work, on the devices we all use.
Absolutely. Something to think about as we use these tools.
Mm-hmm.
Being aware of the memory, the compression, the task complexity, all of that
Right.
helps us make the most of them.
Whether we're using a powerful server or just our phones,
Exactly.
it's almost like learning a new language.
Oh, I like that.
Understanding, the nuances and the limitations.
Yeah.
But once you get it,
Mm-hmm.
so many possibilities open up.
That's a great way to put it. Highlights how important it is to, be curious and keep learning about this stuff.
Right.
The more we understand,
Yeah.
the better we can use these tools effectively and responsibly.
Couldn't have said it better myself.
Thanks.
Thanks for, guiding us through all this
Oh, of course.
complex stuff.
Hit
I
it.
know I learned a lot today,
Me too.
and I hope everyone listening did too.
I hope so.
To everyone out there, keep exploring this stuff.
Yeah, keep
And
lagging.
keep diving deep into the world of AI.